All right. So this is in section 3.7. We're going to talk about absolute value equations. So I just want to give us a reminder a little bit about how absolute value works. So our symbol for absolute value is two vertical bars. So we'd have something like that. That means the absolute value of -3. And the kind of the key piece of information about the absolute value is it makes what's inside positive, always. So the absolute value of -3 is 3. It takes whatever's inside those bars and makes it positive. So for example, the absolute value of 5, it takes whatever's in there and makes it positive. Well, this is already positive, so that's just 5. We also have the possibility, and the absolute value of -5, it takes whatever's inside and makes it positive. That also equals 5. So we have two possibilities here. The absolute value of 5 is 5. The absolute value of -5 is also 5. When we start solving equations, absolute value equations are always going to have two answers because of these two possibilities for our absolute value. We can think of the absolute value as the distance from the origin. So if I draw this on a number line, there's 0, 1, 2, 3, 4, 5. 5 is 5 units or 5 spaces from 0. And if I go the other way, 1, 2, 3, 4, 5, there's -5. -5 is also 5 spaces from 0. So our absolute value tells us how far this thing is from 0, from the origin. So when we say the absolute value of -3 is 3, that means that that means that -3, there's 0, 1, 2, 3. -3 is 3 spaces, 3 units from the origin. That's what absolute value means if we think about it in terms of geometrically, or on the number line. But we always have two possibilities for how far something is from the origin. We can have the positive possibility and the negative possibility. So when we solve absolute value equations, we always get two answers. All right, any questions on the kind of the basic idea of what absolute value is?
Is the origin always 0?
Our origin is always 0. And if we were talking about the xy plane, it's 0, 0, where both things are 0. All right, so solving equations is really what we want to do. And for absolute value equations, I'm going to write down some steps here for our absolute value equations. We want to get, well, I'm going to start by saying we always have two answers. So we always have two answers for absolute value equations. So our step, just like solving equations, we solve absolute value equations just like we've solved other equations. We want to get the absolute value by itself. So we add things to both sides, subtract things from both sides, multiply, whatever, to get the absolute value by itself on one side of the equation. And then we're going to split it into two equations. And one is going to be positive, and one is going to be negative. Just like we have the two possibilities for how far something is from the origin, we have a positive possibility and a negative possibility. We do the same thing with our equation. But the steps to solve are the same until we split it at the end. So let's look at an example. The absolute value of x plus 3 equals 7. We want to get the absolute value by itself. So we want to get this 3 away from the absolute value. So what are we going to start by doing? Subtract 3 from both sides. So I get the absolute value of x equals 4. And now we're going to split this into two equations. So I get that x equals 4 or x equals negative 4. One positive, one negative. And we can check our work. I'm going to go over here and check. The absolute value of 4 plus 3. Well, what's the absolute value of 4? It's always positive, so it's 4. 4 plus 3 is 7. The absolute value of negative 4 plus 3. The absolute value of negative 4 is 4 plus 3 equals 7. So both of them give the answer that we want. And if the problem asks you to graph your solutions, I'm just going to graph on my number line. There's 0. There's one solution. And there's the other solution. I'll do it in blue. We get one positive possibility and one negative possibility. Always with an absolute value equation. All right, questions on what we did there? Everything's the same until we get the absolute value by itself, and then we split it into two equations, one with a positive, one with a negative. All right, let's look at another one, a little more complicated. The absolute value of x minus 3 equals 9. Well, do I have the absolute value by itself already? Yeah, this is the whole thing. We have the absolute value of that whole thing. So we don't need to do anything yet. Now we're going to split this. Once we have the absolute value on one side by itself, then we just split it. I'm going to split this. So x minus 3 equals 9, or x minus 3 equals negative 9. One positive, one negative. And I solve each of these. Add 3. I get x equals 12. Or add 3. I get x equals negative 6. And then I can check my answers. 12 minus 3, the absolute value. Well, what's 12 minus 3? 9. What's the absolute value of 9? 9. Let's check the other one. Negative 6 minus 3, absolute value. What's negative 6 minus 3? Negative 9. And the absolute value of negative 9 is 9. So both my answers check out. Yes?
Does that mean there's two possible answers for this problem?
For every absolute value equation, we get two possible answers. Always. Every single time. That's what I said back here. Always two answers for absolute value equations.
If you go back down a little bit.
This way?
Just like where you were.
Here?
Yeah, thank you.
All right, other questions before we go on? Yes.
Can I go to my notes?
Yes. All right, let's look at another one. 4x plus 1 minus 2 equals 5. So we want to get the absolute value by itself. So I'm going to start by adding 2 to both sides. And I get the absolute value of 4x plus 1 equals 7. Now I have the absolute value by itself on one side. So I'm going to split this. So I get 4x plus 1 equals 7. Or 4x plus 1 equals negative 7. One positive and one negative. Every time we solve an absolute value equation. Well, now I need to get x by itself. For this first one, I subtract 1. So I get 4x equals 6. Divide by 4. And x equals 6 over 4, which I can reduce to 3 halves, or 1.5. If I put it in my calculator. Subtract 1 from both sides again. Here I get 4x equals negative 8. Divide by 4, and I get x equals negative 2. And I can check my answers. I'm going to plug them into the original equation. 4 times 3 halves plus 1, absolute value, minus 2. Well, I can think of 4 times 3 halves is 4 over 1 times 3 over 2. So that's 12 over 2 plus 1. 12 over 2 is 6 plus 1 minus 2. So that's the absolute value of 7 minus 2. Absolute value of 7 is 7. 7 minus 2 is 5. And that's what I wanted to get. I can check this answer. 4 times negative 2, absolute value, plus 1, minus 2. 4 times negative 2 is negative 8. Plus 1, minus 2. Negative 8 plus 1 is negative 7, minus 2. Absolute value of negative 7 is positive 7. Whoops. Minus 2, and I get 5. So I get the right answer for both of my solutions. Now, we don't necessarily have to check every single time we do a problem, but you can check to make sure you've done the problem correctly. Yes?
Can you go up just a little bit?
Sure. Is that far enough? Yes?
So you keep the absolute value the same, but do you make the answer negative and positive?
Yes.
Okay.
Keep the whatever's inside the absolute value, and it equals either something negative or something positive. All right, other questions? Now I want to show you one example where we have to be careful. I'll wait until everybody's set. Okay, let's look at this one. 5 times the absolute value of 3x minus 1 plus 6 equals 3. I want to get the absolute value by itself. So my first step is going to be to subtract 6 from both sides. So we get 5 times the absolute value of 3x minus 1 equals negative 3. I want to get rid of this 5. So I divide by 5. And I get the absolute value of 3x minus 1 equals negative 3/5. This is telling me that I'm taking the absolute value of something and I'm getting an answer that is negative. Well, what does that absolute value do to anything that's inside it? Makes it positive. So this is saying I'm taking whatever's inside here and making it negative. That's impossible. The absolute value of something cannot be negative. So the absolute value of a thing is never negative. So this is no solution.
How did you get equal to negative?
I divided both sides of this by 5. So when I subtracted 6, I got negative 3. Divided by 5, I get the absolute value of 3x minus 1 equals negative 3/5. So if you get that the absolute value of something equals something negative, you get no solution. The absolute value of a thing can never be negative.
I put a star or something by that in your notes just so you remember it. It's something that kids get tripped up on a little bit.
And don't get confused with back here where we split our answer into two things. Here we're saying what's inside the absolute value is 7 or negative 7. We're saying that this thing that's inside can be positive or negative. This is telling us that what we get out of this is negative. So it's okay once we split this into two equations, if this is positive, to say it's positive or negative. But this is saying what we get out is negative, which is impossible for an absolute value. Yes.
So the answer to an absolute value always has to be positive.
Yes. The answer to an absolute value is always positive. We can, if that helps, to make a note of that.
Can you go back one page?
Just a second. Value. And don't confuse that with the solution to our equation being always positive, but the absolute value of something is always positive. All right, so I'm going to go back one page. All right. Other questions? Okay, let's look at one last example just to make sure that we have this. Did I do this? Yeah, I wanted this to be here. There we go. Two times the absolute value of 2x minus 3 minus 1 equals 11. I want to get the absolute value by itself. So the first thing I'm going to do is add 1 to both sides. So 2 times the absolute value of 2x minus 3 equals 12. I want to get the absolute value by itself. So my next step is going to be divide by 2. These cancel. I get the absolute value of 2x minus 3 equals 6. This is positive. That's good. It's saying what we get out of this absolute value is positive. Now I can split this. And I'm going to say what's inside. 2x minus 3 can be 6. Or what's inside 2x minus 3 can be negative 6. And now I solve for x. So 2x equals (9). Divide by 2, and x equals 9/2. Or add 3 to both sides here. I get 2x equals negative 6 plus 3 is negative 3. And then divide by 2, and I get x equals negative 3/2. So those are my two answers. Yes?
Do they have to be the same answer? For like the x equals when you check it?
Yes. So if we plug each of these into our original equation, each one should give us 11.
Okay.
Where would we plug them in?
In the original equation for x.
Ah.
And just simplify this left-hand side and see if you get 11. Now you don't have to check every answer, but you can check your answers. Yes? What's that? No. You get two different answers. Sometimes you'll get an answer like the first ones we did. One is positive 5 and one is negative 5, something like that. But they're not going to be equal to each other. All right. Questions? So absolute value equations, we always get two answers. We get the absolute value equation, absolute value by itself, and then split it into two equations. But our absolute value always has to equal something that's positive. So if we get the absolute value of something is negative, like we did here, then we get no solution. All right. Our homework is in section 3.7. And this is page 211. (10 through 30), every other even, and number 64.